Okay, so question number 3. What is the Lewis structure of ammonium chloride? Okay, so when we write out the Lewis structure, we first want to calculate the total number of valence electrons. Okay, so for nitrogen has 5 valence electrons. Hydrogen has 1, and we have 2 hydrogen atoms in this compound, so we multiply this by 2. And chlorine has 7 valence electrons. Okay, so if we add these all up, we should get 14 valence electrons in total in our structure. So now let's try to draw out the skeletal structure. We'll have nitrogen as our central atom, and then I'm just going to draw down single bonds to my 2 hydrogens and to my chlorine. So now that we have the skeletal structure, I can show all the lone pairs on my terminal atoms. So in the case of hydrogen will have no lone pairs since it only has 1 valence electron, and that is participating in the single bond. So it has no more electrons, so that's why hydrogen will never have any lone pairs on it. In the case of chlorine will have 6 valence electrons. And now I like to count out how many electrons I've drawn so far. So each bond contains 2 bonding electrons, and my chlorine has the 6, so we only have 12 written down so far. So for the remaining 2 electrons, I'm going to put them on my central nitrogen atom. Okay, so we have the Lewis structure for ammonium chloride. So now let's see what the junior tutor said. Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes even radicals. It contains some trial and error, so there are some guides and rules in following it. So this is a step-by-step guide, so it's pretty much what we did. We determined the central atom, which was nitrogen, logically arranged the atoms. So if you know that this atom is able to form multiple bonds, then it's helpful to know that it would probably be the central atom. And also, usually the least electronegative, with the exception of hydrogen, is typically the central atom as well. Connect the atoms and then check the rules below are followed. If not, make necessary adjustments. Redraw the entire molecule if needed, so hopefully you don't get to that step. But now they have the rules. Make sure atoms that follow the octet state strictly have 8 valence electrons. Minimize formal charges. More electronegative atoms are given the negative formal charge if applicable. And make sure the sum of the formal charges match the charge of the compound. So we don't have a charge in our compound, so that doesn't pertain to us. And now they have their example, and they got the same Lewis structure I did as well. And they also have the equation for formal charge, which is helpful. But if we were to calculate it for all of our atoms, we should get a formal charge of 0 for all of them. So the solution is correct.